Yeah, I got this one right. I don't trust my arithmetic. I think somebody came to my office yesterday and they got some numerical thing wrong and I said, I don't know, I don't care about it. But at the end, that's the mathematician's side. I don't care. I care more that you got the process right. All right, so here's where my wheels were spinning. I went in order. I said, let me start here and let me start here. And then the feeling you get when the feeling I get is there's got to be an easier way. So I'm messing with this 50,000. I got one sale. I think, well, I could get one sale because they contacted one person, and then they contacted two people, and one of them ended up with a sale, and that seems yucky and complicated. So, you think going through the possibilities. Some of you were doing that on the homework. You're going through the possibilities, and there seems like there's weird possibilities that you have to think through. Either your events were set up wrong, so you kind of like, well, no, something's up. There's got to be an easier way. They can't be this convoluted and complicated. So I gave up on trying to find the $50,000 one, and I went to the $100,000, which was pretty easy. And I said, well, I got these two, and now I've got all possibilities, so I just subtract them from one. And so that gave me the last possibility. So that's a trick. So you want to remember that trick when you have three or a few things that you calculated that seemed easy, and the one that's left over seems hard, then you can use that trick to get that. And I felt like we used that quite a bit last semester. Not only do you write fast, you write neat. That's good. Okay, so that's what they mean by probability distribution. That's on page 88. They just want those numbers. All right, now they want you to find the mean and standard deviation. You go to the formula. The formula is on page 91. And I used my wrong number in there, but so the formula says take the sum over all the little y's that you have. I have 3 little y's. Now I have 3 terms. I don't like summation notation. I'd write it out and just say this is what it is. Because that is what it is, and I just calculated it. Y times P of Y, just plug them in. And you're always going to go back to that definition. So it's not, you're not like in 206 adding up a whole bunch of stuff and dividing by the number. You're going back to that definition of expected value. Okay, standard deviation. It's that thing. Formula from the book. So what does that mean? It's exactly what you just plug and chug. You stick in the y, you take off the mean, which you already have, square it, and then calculate one by one. And whatever the heck this number was, I started like worrying about my arithmetic. Whatever the heck this number is, you just take the square root of that, and that's the standard deviation. And that's on page 93.
And what's the mu again?
Mu is the expected value.
And the y?
The little y are all the possibilities of what you found in the discrete. So little y could be 0, little y could be 50,000, and little y could be 100,000. So 0, 50,000, 100,000. Good? Yeah, sure. So the point of me doing this problem was just to show you my approach to how you just always go back to the definitions. I'm listing the pages. I'm listing the pages not just for you, but also for me to remember where I found these things. And you should be doing that in your homework. I found this, I'm using definition this right now. I'm using theorem this right now, and justify what you're doing as you're doing it. Okay, so I'm gonna have you work on a board problem.
Wait, what was the final answer?
Oh, I didn't crunch out that
Oh, okay.
arithmetic. You probably don't want me to do the arithmetic.
That's just the answer?
Yeah, so you put this on a calculator or Mathematica or whatever you want. It's just a bunch of numbers.
And then you take the square root of it.
And then you take the square root of that ugly thing. Good? All right, so I looked at your homework problems and your first homework problem already has a binomial distribution. So I thought I'd give you a problem with binomial distribution. But, you know, no matter what I tell you in here, I can show you binomial distribution, you're still gonna have to look in your book, find the definitions, pull them out. So try the same approach I did for this problem. You can't take boards right away. You're gonna have to like scratch some out. And I tried to pick something that was as close to your number one as possible so that you can get a feel for it.